This is A. Fatima Begum, Assistant Professor of Mathematics, Jamal Muhammad College, Trichy.
Dear learners, in this video we will see calendar in quantitative aptitude. Calendar is a sequence of pages which contains information about the day, week and the month of the particular year, and also it may contain some seasonal information too. In calendar, these information are arranged in systematic way. The questions on these topics are common in various competitive examinations such as TNPSC, bank exam, SET, NET, etc. We are supposed to find the day of the week. The method of solving such questions lies in the concept of obtaining the number of odd days. Before moving to odd days, let me explain some basic definitions which are very essential to understand the entire concept clearly. Classification of years. A year can be classified as a century year and a non-century year. Century year is a year which can be written as multiple of 100. That is, the last two digits of the century year must be 0. A year which is not a century year is known as non-century year. Each century year and a non-century year can further be classified as ordinary year, leap year. Ordinary year has 365 days, where leap year has 366 days. There are two different ways of finding the leap year in according to a non-century year and a century year. Let's first see for a non-century year. A non-century year which is exactly divisible by 4 is a leap year. Exactly divisible by 4 means when we divide the given year by 4, we must get remainder as 0. Examples: 1948, 2004, 1676, all these are non-century leap year. Let's now see for a century year. In a century year, every fourth century is a leap year and no other century is a leap year. Every fourth century means the year which can be written as multiple of 400 is known as fourth century year. It can also be stated as in a century year, the year which is exactly divisible by 400 is a leap year. Examples: 400, 800, 1600, all these are century leap year. Ordinary year. The year which is not a leap year is called an ordinary year. An ordinary year has 365 days. Examples: 2001 is a non-century ordinary year, where 300 and 2100 are century ordinary year. Let's do some exercise here. The year 100 is not a leap year. Is it correct statement? 100 is a century year which is not exactly divisible by 400. Therefore, 100 is a ordinary year, not a leap year is a correct statement. 1996 is an ordinary year. 1996 is a non-century year. When we divide 1996 by 4, we get remainder 0. Therefore, 1996 is a leap year. Ordinary year is a wrong statement. 1800 is a leap year. 1800 is a century year which is not exactly divisible by 400. Therefore, 1800 is an ordinary year. The given statement is wrong. 2000 is not an ordinary year. 2000 is a century year which is exactly divisible by 400. Therefore, 2000 is a leap year. Not an ordinary year is a correct statement. 200 is an ordinary year. 200 is a century year which is not exactly divisible by 400. Therefore, 200 is an ordinary year. Now, move to the concept of odd day. In a given period, the number of days more than the complete weeks are called as odd days. Suppose we have given number of days. From this number of days, we have to form number of complete weeks. After forming complete weeks, obviously we left with some days which are not sufficient to form another complete week. This number of days is known as number of odd days. The number of odd days must be lies between 0 and 6. To make it clearly, let me explain by giving the example. Suppose we have given by 9 number of days. From these 9 days, we can form a complete week by using first 7 days. And we left with 2 days, 8 and 9. These 2 days are called as 2 odd days. Kindly note that number of odd days always lies at the end of the given period. The last date of the given period is the last odd day. In this example, the last date is 9, therefore 9 is the second odd day and 8 is the first odd day. Suppose the starting day of the given period is Friday. Here the starting date is 1, therefore Friday falls on 1. By using this, can we determine the day of the first odd day? Yes, we can. The starting day of the given period must be the day of the first odd day. By using the day of the first odd day, we can determine the day of the remaining odd days. Here 4 points to be remembered. First point is number of odd days always lies between 0 and 6. Second point is the number of odd days always falls at the end of the given period. Third point is the last date of the given period will be the last odd day. Fourth point is the starting day of the given period will be the day of the first odd day. Counting of odd days. Consider an ordinary year equal to 365 days. By using these 365 days, how many weeks can we form? To get that, we have to divide this 365 by 7. We get quotient 52 and a remainder 1. 52 means 52 weeks. 52 into 7 equal to 364 days. Among these 365 days, we use 364 days to form 52 complete weeks. And we left with only 1 day. That 1 day is known as odd day. Therefore, every ordinary year has 1 odd day. Consider a leap year equal to 366 days equal to 52 weeks plus 2 days. Therefore, every leap year has 2 odd days. Consider 100 years. Here, I am not talking about the particular year 100. I am talking about group of years from the year 1 to the year 100. These 100 years can be classified as century year and a non-century year. The year 100 is the century year. Remaining 1 to 99 years are non-century year. Among these 99 years, how many leap years occurs? To get that, we have to divide 99 by 4. We get quotient 24. Therefore, in 99 years, 24 leap years occurs. 99 minus 24, 75 ordinary years occurs. Now come to the year 100. 100 is a century year which is not exactly divisible by 400. Therefore, the year 100 is the ordinary year. Already we have 75 ordinary year. By adding this 100 year to, we get 76 ordinary years. Therefore, in 100 years, we have 76 ordinary years and 24 leap years. Every ordinary year has 1 odd day. Every leap year has 2 odd days. Therefore, 76 into 1 plus 24 into 2, 76 plus 48, we get 124 odd days. Since 124 is greater than 6, we can form number of weeks. When we divide 124 by 7, we get quotient 17 plus remainder 5. Therefore, number of odd days in 100 years equal to 5 odd days. Here the given period is starting from the year 1 to the year 100. Therefore, the last date of the given period is 31st December in the year 100. 31st December in the year 100 will be the 5th odd day. Number of odd days in 100 years equal to 5 odd days. Number of odd days in 200 years equal to 5 into 2 equal to 10 days equal to 1 week plus 3 days equal to 3 odd days. Number of odd days in 300 years equal to 5 into 3 equal to 15 days equal to 2 weeks plus 1 day equal to 1 odd day. Number of odd days in 400 years equal to 5 into 4 plus 1. Why we add 1 here? Since 100, 200, 300 are century ordinary year, where 400 is the century leap year. It has 1 odd day more. that odd day we have to be added here, which is equal to 21 days equal to 3 weeks plus 0 days equal to 0 odd day. Now the given period is starting from the year 1 to the year 400. If the starting day of the given period is Sunday, that is 1st January in the first year is Sunday, then 31st December in the year 400 will be Saturday, since there is no odd day. So it must be end of the week. Similarly, each one of in 800 years, in 1200 years, in 1600 years, in 2000 years, etc. has 0 odd day. That means whenever we consider from the year 1 to the century leap year as the given period, the number of odd days must be 0. In competitive examinations, there are 3 types of questions are frequently asked in this section. In the first type, only one date is given in the problem. We have to find the day of that given date. In second type, 2 dates are given in the problem. The date which is given along with its date is the reference date, and we have to find the day of the another given date by using that reference date. In third type, a year or month will be given in the problem. We have to find the year or month which possesses the same calendar of the given year of month. Day of the week related to odd days when the reference date is not given. This table is used in the first type problem. That is, only one date is given in the problem. We have to find the day of that given date. Suppose we get number of odd days as 0, then 0 denotes Sunday, 1 denotes Monday, 2 denotes Tuesday, 3 denotes Wednesday, 4 denotes Thursday, 5 denotes Friday, 6 denotes Saturday. Till we have seen important concepts which are very essential to do calendar problems. In the next video, we will see some examples related to this concept. Thank you for watching this video.